Hey everyone, moving on to the third technique in our Maclaurin series, we have the logarithm expansion. The logarithm expansion is actually rather similar to the binomial expansion because if you look at the formula, again, for in the MF26, you notice that there is this constant and it must be 1. And again, this can be fx. The thing is, for fx, it must be purely algebraic, right, for now. Right, so fx is algebraic, and there must not be any constant. All right, no constant. All right, soon enough you see that we can actually combine with the other techniques, but we put that for later. All right, so when it's no constant, it's just purely 1 plus x. So what do you do if, let's say, you have ln 2 plus fx? All right, or we can use a more general form. Maybe let's look at ln a plus fx. If you recall, by the law of logarithms, right? Law of logarithms states that if we have ln a and b, it's basically ln a plus ln b. So we apply that here. If you have ln a plus fx, you will take out ln a. Then we have plus ln 1 plus fx over a because you divided the function by a. So let's take a look at some simple examples. Let's say, going back to the constant 2, let's say we have ln 2 plus, let's put it very simple one, plus x. So we know what to do, right? Just basically factorize out the 2 first to give us ln 2 plus ln 1 plus x over 2. Then from here, it's just following the formula, right? So we have ln 2 plus, let's say we want until x cubed, all right? So if x equals to x over 2, right? Fx is basically x over 2, so just substitute all the x right here into x over 2. So if x over 2 minus away x over 2 whole thing squared over 2 plus x over 2 whole thing cubed over 3. Then you have plus dot dot dot. So from here, it's rather simple, right? It's just ln 2 plus x over 2 minus x squared over 8 plus x cubed over 24 and so on. Again, if you use the approximation sign, you do not need the ellipses at the end. Now let's move on to a slightly different example. Let's say we have ln 3 minus x squared. So it's the same thing, all right? Do not worry. So we just continue as per usual. Same first thing first, get rid of the constant 3 to make it plus 1. So make it constant 1. Therefore, you have ln 3 plus ln 1 minus x squared over 3. From here, again, you just want until x cubed, right? Thing is, now that your fx is x squared over 3, so you actually don't need the x squared. You need to actually put in to x squared. What do I mean? I'll show you later. So x equals to, now it's minus x squared over 3. Then next one is actually minus x squared over 3 whole thing squared. But this will give us power 4, which we don't need. So we can just cancel this away. And then we just add a plus dot dot dot. This would then land us with ln 3 minus x squared over 3 plus dot dot dot. Alright, so again, very simple one. It's similar to a binomial expansion, just that, don't forget, when you are to factorize this, it's always ln a plus ln 1 plus fx over a. Simply put, follow the law of logarithm. So there we have it, the Maclaurin series for logarithm.